One of the really powerful uses of the factor theorem is to factorize polynomials. Because if we can find a factor, it makes it that much easier to then find the other factors. So here, what we do is we start by just substituting values in. Let's start with 1. F of 1 is 1 plus 3 minus 33 minus 35. Now that is not equal to 0. That means we haven't found a factor. If we substitute in negative 1, we get negative 1 plus 3 plus 33 minus 35. Now here we have 36 and minus 36, which means this one is equal to 0. But the factor theorem tells us that if when we substitute minus 1 in we get 0 out, that means that x plus 1 is a factor. Now we know that x plus 1 is a factor, and we know that this polynomial can be written as x plus 1 times by some other factor, and that other factor has to be a quadratic. Now to find that quadratic, we're going to use something we saw in the previous skill when we were dealing with polynomials. We could do this using polynomial division. You could do this thing divided by x plus 1 to find this. That would be absolutely fine. Or we can do the quick method by inspection. Given that we have to get minus 35 as our constant term, and we've got 1 here, we can immediately see that this has to be minus 35. Similarly, we have x and we need x cubed, so this is going to have to be x squared. The last step is to find that minus 33x. How could we get x's? We've got minus 35x already, so we need to add on 2x. The 2x comes from multiplying the 1 by this term here, so this is going to have to be plus 2x. Does that work for the 3x squared? We have 1x squared plus 2x squared, that is indeed 3x squared. Finally, to complete this factorization, that quadratic, we're going to factorize into 2 linear parts. To get to 35, we're going to have 5 and 7. It's going to be plus 7 and x minus 5. And we have now fully factorized that polynomial into 3 linear factors. Remember, we know that a cubic can have at most 3 linear factors. Some of them could be repeated, or it could be a linear factor and a quadratic factor that cannot be factorized any further if there are 2 imaginary roots. We know that from the fundamental theorem of algebra that we saw a few skill sheets back. So this is one very useful use of the factor theorem to help us try and factorize higher order polynomials, essentially with a little bit of trial and error to start with, and then once we've done that, we can then go on to factorize quadratics that we've managed to factorize out.